Okay, so today we're going to be using the law of exponents, and by the end of this one you should be able to, when given a exponential expression, or given an expression with lots of exponential expressions, you should be able to rewrite that expression more simplistically, clean it up a little bit, and then look at some square roots and cube roots and do the same thing with those expressions. Do the same thing with those. All right, but before we do any of that, let's go ahead and review some stuff about exponents. Okay, so remember, you have a base, and in my explanation we're going to call the bases, we're going to use A and B as the bases, as the base letters. Okay, these represent numbers, right? And then those are raised to like an exponent of m or n, right? So these are the bases, and then these are the exponents, right? So real simply, you guys probably remember, it's like 5 to the 5th. It's like you multiply the things by the number of times that you said it. So 5 times 5 times 5 times 5 times 5 is 5 to the 5th. Okay, but anyway, so base and exponents. All right, so let's start with what I think is the simplest, and then the names that they give these are confusing, super confusing. They sound similar enough to get them confused and compared to the other ones. So I might not even just not name them. I'm just going to go over the relationships, because the relationships are what matter, okay, in all of math. They name them to try to differentiate them, but the relationships are what matter, okay? So the first one is the identity. This one's easy to remember. If you can spell it. Identity. Exponent. Okay, so if you have a base raised to the first, okay, so anything like 6 raised to the first, it's itself. 2 raised to the first, it's itself. Pi raised to the first, it's itself. Okay, so anything raised to itself equals itself. Okay, that one's easy to remember. All right, the next one isn't intuitive. It's not intuitive. This is the 0 exponent, and I will prove it to you if you want me to prove it to you, but I'm not going to do it in this video. You have to come and ask. I'll prove it to you, but it doesn't. I'm just going to have you check the I believe button. A is any base raised to the 0th power equals 1, right? Every time, right? 8 to the 0th equals 1. Pi to the 0th equals 1, right? And it all has a spin off of another one, a quotient of powers. And you'll see that here in a minute. But here's the I believe button. Need you to push the I believe button on this one. It'll be easy for you if you push the I believe button and just remember that one. Okay, but I will prove it to you if you want me to prove it to you. You can also watch a YouTube video, which there are many. All right, so now let's go over the negative exponent. And there's a button for this one on your calculator. Instead of A, they use X. Okay, so if I put, like, everyone knows 1/2, right? And if I push that button there, I get a 2, right? That's the invert button, right? Because if I take anything A, right? If if I rewrite A as itself, I can put a 1 over top of it. Let me relate that up. Oh, I put it, and it still equals A. This equals A. Those are the same, right? Okay, but if I put a -1 over top of this, like that, right, it will turn into 1 over A, like that. All right, so I'm going to go ahead and erase that. That is one of the negative exponents. Okay, so similarly, if I take like oops, these should be orange. These should be orange. -1, -1. Okay. Similarly, if I do like an A over B, and A over B, right? And I do like put this in the parentheses, and I put a -1 over that. Say like it's a 2/3, right? And I do one of these. It turns into 3/2. 3/2. 3/2, right? Because all I did was flip it. Turns into B over A, right? I just flipped it. Okay, and this doesn't always have to be 1, right? The exponent doesn't always have to be -1, right? I can turn this into like BA or AB, and I can raise this to any value represented as -m, right? And then it would flip it. It would flip it, and it would flip it, right? So let's flip it, B, A, and it would become to the mth power, m to the micth power, right? Not only that, but it would distribute it to the B to the m divided by A to the m, A to the m. Right, because it did the same thing over here, right? This just went 1 to the 1. They just don't show it because it's 1. Okay? So, that is the negative exponent one. Okay, now let's do the product. This is where the names get confusing. Okay, the product of powers. Okay, so the product of powers is, let's think of a really easy one. Say I have A times A. They don't show it, but the exponents are 1 on these, right? So this equals A squared. Everybody knows that. It's pretty straightforward. Well, why does it equal A squared? Well, we added the exponents together. Okay, well, if we do an A, we'll say 2 squared times an A, whoops, and an A to the 3rd, well, we just add those together too. Product of powers, when you're multiplying something with the same base, you add exponents. You guys remember that? All right, this is going to be equals A to the 5th. All right, A to the 5th. Add the exponents. Product of powers. All right, quotient of powers. Dividing. G-O-T-I-E, quotient of powers. All right, so we have an A divided by a B, and we have a, let's see, an M and an N, right? Remember, products are adding. Quotients are the opposite of adding. So what do you quotient or so this is multiplication, and you add the exponents. This is division. So what do you think you do with the exponents? If you're thinking you subtract them, you would be correct, right? So this would be equal to. Sorry, this needs to be the same base. Same base. Sorry about that. Same base. Same base. This would be equal to A, and then you subtract exponents. I'm just going to abbreviate exponents, EXP. Okay? That's the quotient of powers. Okay. All right. So now we have this one is the power of powers. Power of powers. And this, if you're given all of the same numbers and you plug it into all of the exponent laws, this one is most likely to yield the largest number. Okay, so say you have a base. This is the same base. And there's two exponents. Same power of power. Two exponents, right? You have one base and two exponents, right? To an m to the n, right? This equals a to the m times the n, okay? So you could see why this would be the largest, because then you'd raise this to the whatever the times that is, unless like this is a 1 or something like that, then it might not be as big. Okay, most likely. All right, so now we get into the only two of the. Never mind. I'm not going to say that. Don't want to confuse you. All right, so then we have the power of a product. Power of a product. And this does not have the same base, right? So you have a product, A, with two bases, A times B, two bases, right? And it has one power to the m, right? This is where you're going to distribute this product onto both and multiply them together, right? So it's going to be A to the m times B, times B to the m. Okay? It says two bases. Two bases. Okay? And then we have the power of a quotient. So the power of a quotient, right? Only one power, okay? So you have a quotient, an A divided by a B raised to a single power, okay? One power, and the quotient is one thing divided by another thing. Thing 1 divided by thing 2, right? A divided by B. And that's gonna yield you an A divided by an M divided by a B divided by an M. And look what that kind of looks like. That kind of looks like this, right? Except without the flippy floppy, right? Except without the flippy floppy. Okay, so that is the exponent laws, right? So this is the first part of 1.4, and I'm going to call out one video.